invite the speakers, and we have two discussants, Dr. Gomez from University of Virginia and Davis from University of Arizona. And our request to them was to bring brief additional points or even challenge the speakers. And hopefully we'll have enough time to get, again, some questions from the audience for your interventions. Please come forward. Yep, you see your name somewhere there? Okay, good. So the discussants, please start us off with brief remarks. 5 minutes, not more than 5 minutes. There's a button.
Push this.
Yes.
There you
okay.
go. You got it.
Okay. Thank you. Technologically impaired, as I am. So just a very brief remark. There are lots of experts in the audience. And I think Tom, my colleague, Tom Davis, and I would like hopefully to stimulate the discussion. And please participate as much as you can. And then the other thing is that we would love for the speakers and yourselves also to be more respectful. This is fades in and out. I don't know. Well, so a crucial problem for organ regeneration, as well as for development of organs in vitro, is the development of the vasculature. A case in point is the kidney. You can put the kidney in culture, a embryonic kidney that develops all the nephrons perfectly. They are oriented, etc., but they do not develop a vasculature. So maybe throughout this conversation, as well as throughout the meeting, it might be worthwhile to consider what are the barriers for this vasculature, to understand how this vasculature can actually be developed in vitro. And I'm not going to ask the question now, but you think about it and maybe come up in a few minutes with some ideas. I hope this permeates some of our discussion. Now, we talk about connections today, and Dr. Pierre Scottle gave a wonderful talk about it. And it is a remarkable feat that blood vessels connect perfectly. And again, I'm going to bring something from the kidney as well as the brain. Tom will talk about that, in which the arterioles of the kidney make this perfect connection with each glomeruli. And this is incredible because there are about 1 million glomeruli, and there are no known, at least I'm surprised that there are no more microvascular abnormalities. So this is very tightly regulated. Now, the questions that I have are going to be broad, that we have, are broad on purpose to stimulate the discussion. And one is, so what are the mechanisms? We didn't talk about the mechanisms, be it molecular mechanisms or physical factors that determine this precise temporal and spatial arrangement of the vasculature in any organ, and its shape, its branching, as well as its size. And I can start, Dr. Pierre Scottle, to ask my question from before was, is it random or is it organized, and how much of each?
Okay, so I guess this is a question about the role of stochasticity, randomness, versus deterministic signals like growth factors and
I think that may be the problem. Maybe that's the problem. It's not joined.
Right? I mean, I don't think we have a good answer. You said something that's really interesting, that we get perfect connections and a beautifully, exquisitely, perfectly formed network. And I always find myself thinking this is a thing. And then I wonder, is it maybe that, or perhaps is it a very noisy system where there is stochasticity and randomness and chaos sort of bubbling up, but it's kept in check by the right feedback control systems?
And I don't think lost. I don't think we have an answer. I can just end by saying we are trying to use computational approaches where we can simulate these processes using stochastic rules, if you will, or more deterministic rules. And by doing that, we can see sort of what outcomes or predictions our models make. And by comparing that to what we observe in our experimental systems, we can try to get a grip. I think the answer is it's going to be a combination of randomness and deterministic.
Thank you. How about some remarks from the audience regarding these issues? Does anybody? Please, please.
Well, I think I can project.
Sing.
Nobody wants us to do that.
Question by asking differently.
Okay.
Oh, well, I think the big deal is to make one circulation in one glomeruli. So if the nature organized that, then the rest is just replicating, right? But not to replicate too many. So that's also one way to look. And I'm not saying I know the answer, but this is just an opposite way.
Okay, that's a good idea to go that way. Tom, somebody else has any ideas about this? How is shape determined? How is the branching pattern determined? Many of you work on this day and night. Question? Yes, please.
A question regarding the microvascular disease and the effect of estrogen or other hormones along with the glucose. So Dr. Miller's presentation was excellent from the hormonal point of view. But besides the effect of the hormone, the glucose also plays a very important role in diabetic retinopathy. So how do they, both of them come together to accentuate the effect of the aging effect and other pathology on the white matter hyperintensity as well as other microvascular disease in the kidneys and retina?
Okay, is this working? Okay.
See? It all defaulted. Oh, so it's defaulted. Yeah.
That one, all righty. Here we go. Here we go. Close up and personal. Thank you for that question. Clearly, there are interactions between how the sex chromosomes, the presence or absence of the sex hormones, and metabolism are going to affect the cell. The development of type 2 diabetes in women is changing with the demographics of obesity in this country. So we used to think about type 2 diabetes risk being increased at menopause. I think now we need to go back and say, how does ovarian function affect the development of type 2 diabetes over the lifespan, especially in individuals, for example, that have polycystic ovarian syndrome, who may have a metabolic syndrome but be not prone to have some type 2 diabetes activity and vice versa. So the interaction of them, I think, needs to be studied. Typically, many of the models for diabetes have been male animals. I think we need to be able to use female animals who have either are virgins or have had in pregnancy or after pregnancy, dams that have experienced multiple pregnancies, because clearly if you look at the clinical literature in terms of risks for some future disease, whether or not you've experienced a pregnancy, multiple pregnancies, or a pregnancy disorder is going to affect your propensity for disease going forward. All these interactions are incredibly important. They haven't been studied and need to be.
A short question regarding the white matter intensity to the neuronal death. Is it because of the microemboli from the platelet vesicles?
We think it's a combination. We haven't been able to sort it out, so it's an effect of how the microvesicles may affect capillary function, how it affects the larger blood vessels in terms of structuring endothelium arterial lesions in the larger blood vessels, which will affect blood pressure. We have to think of it in terms of an integrated system. And if there's one thing I would like for you to take away, two things. One, sex does matter. Sex is biology. And two, we have to think integration. We can't just pull out the brain independent of the rest of the circulatory system.
I would like Dr. Thomas to make his comments.
Marilyn, go ahead.
Okay, just one quick comment, Virginia. I really appreciate pregnancy being involved in all of this, and I think it's really important, but be very careful about gestational diabetes is very different than what you just talked about, which is having diabetes during pregnancy. Just
Okay, thank you. I have an additional perspective I'd like to add, and it's mostly regarding the cerebral microcirculation. And I'd like the whole group to think about this, and then I have a question and a gap I want to fill. Let's not forget that the cerebral endothelial cells of these cerebral microvessels have open to them a 20 square meter interface with the blood. This is an opportunity to deliver drugs. If we're going to deliver drugs, we're going to develop therapeutics that can get into the CNS. We need to stop blaming the blood-brain barrier, because one of the biggest gaps I see from bench to bedside is our thought that this barrier cannot be permeated by drugs due to the lack of success for a number of years. I think the lack of success, if you go back to 1918 when Stern and Rothland developed the term blood-brain barrier, a lot of people hung with that for a long time thinking that nothing would get in and basically walk away. Fortunately, in 2002, when NINDS had their stroke progress review group, they came up with a concept, well, they coined the term neurovascular unit to show the interaction of the various cell types. So what's the point? These specialized cells that have the cell-cell adhesion complex that obliterates that paracellular space with these tight junctions, I see it as an opportunity. I also see it as a moving target. So to get at that, my question is for Dr. Aird mostly, actually, to be truthful with you. Endothelial cells. Does the blood-brain barrier formation in the cerebral endothelial cells coincide with the early vascularization of the growing CNS? And when does the endothelial cell develop this barrier actual morphology? When does it actually function as a barrier? And what can we learn from that can help us understand the flexibility of this barrier and its moving target aspects as we try to develop therapeutics that can get across it?
Is that a test? I'm not a blood-brain barrier expert. I do, I do understand that the blood-brain barrier forms late during development or even postnatally, that the endothelium is not tight during development, and that maybe we can learn something about that transition. But is that wrong? Well,
We have a session on blood-brain barrier, so we could wait. Wait, go.
so yeah, please.
Go to the microphone. Microphone again.
Oh no, please rescue me here.
This is a group discussion.
Okay, well, no, I know Richard Anneman paper, for example, showed that blood-brain barrier forms embryonic day 12, 13, and the pericytes invade and astrocyte came later.
What species are we talking about?
We're talking about mouse.
Mouse, okay.
Yeah. So of humans, I don't know. I mean, I don't know. But just you know, there is some other papers also showing recently similar situations. So it's developed embryonically.
Okay, so, but yeah.
I think.
There is a convincing evidence that at least by birth in term humans, blood-brain barrier is formed without fenestrations in the most of the areas, with relatively few exceptions. So when does it happen exactly in humans? It is still being studied, but blood-brain barrier is a lot more formed at that point than many people think. And I want to bring another point, and I think Dr. Pierce already alluded a little bit, that microglial cells that enter the brain, the developing brain, fetal brain, much earlier than the blood-brain barrier is being formed. And these are the cells that help blood-brain barrier formation through multiple different mechanisms. So this is something that we as a field should also consider, as when we study mechanisms.
Yeah, maybe I want to Bill to comment a little bit more about the heterogeneity of different organ vessels in different organ. We from the first two talk, Bill and Shan, really focus on the connection of the endothelial cells with surrounding cells. And we know that the therapeutic response is different, the disease is different. So if we emphasize the connection of surrounding cells, so I would imagine the signaling or the communication, a molecular flow from the surrounding cells play a major role determining the disease difference, organ differences in the vascular disease. Should we focus more on the signaling communication from the somatic cells towards endothelial cells? Do we know anything about tissue-specific signaling on this microenvironment?
Zarina tells me there's a session on this coming up, but I would just point.
I invite everybody to actually look up the program. So try to focus your questions for this specific topic. At the end of the day, we'll have a general topic and very challenging, interesting questions such as those asked. The very challenging questions you can think and discuss over lunch, and we can come back, all of us, at the end of the day. Please focus your question to...
But I would just echo very quickly something that I pointed out, and that is that those phenotypes that are mediated by the microenvironment, for example, by cell-cell communication, are amenable to therapies directed at that interaction. Absolutely. I see David at the microphone. He may remind us that in dogfish shark, that actually the blood-brain barrier is mediated by the glial cells and not by endothelial cells.
Yeah, in sharks and hagfish, in sharks, hagfish, in the very lower vertebrates, the elasmobranchs, it's a glial barrier, as it is in the fruit fly, in fact. Since I've got the mic, I want to move away from that question to another one that sort of troubled me. Many of us are living off of mouse models, and there are lots of strains of mice, and the question that I'm thinking that's forming in my mind is, if you look at the development of the microvasculature, not just in the brain, which is where I live, but in other organs, could the differences in the structure of the microvasculature in those organs explain some of the propensities of some of these strains to have specific diseases that are much more common or much more severe than other strains? So there.
Okay, I would like to just add to that about the strains of mice. I mean, how many of you actually pay attention to what the sex of those strains of mice might be, or these fancy-dancy? Some of you, there's a few hands going up, but if you pull out a lot of papers that use genetically altered mice, they mix together males and females, and some of them, I've been on IACUC, I know what the protocols look like. It makes my hair curl without a curling iron. And you know, we need to pay attention that these might provide us important clues if the particular genotype is not expressing a phenotype in a male compared to a female. That may provide us really important information rather than just killing all the females as they come out because they're too expensive to keep.
So in general, genetic background, including sex, is very important in those things. There's a number of other people that want to ask questions.
Yes, we have a break coming up now. We are actually over time, so they're welcome to ask questions to the speakers directly or to keep them for the end of the day where we'll have more opportunities to discuss. So we care about your questions.
Okay.
Just keep them until later.
They were warming up. They were warming
yes.
up to the discussion.
So